Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth in its early stages and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them Maria, which means seas in Latin. Other astronomers also made maps of the moon, and they used the term Maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the moon would just disappear right away. They believed the moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the moon in special areas called permanently shadowed regions. These are spots on the moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the moon's poles. They still weren't certain, so they kept digging and, after a while, found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the moon today, which means water probably was present on the moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too? Well, guess what? Blue Origin, the company owned by Jeff Bezos, has sent dinosaur bones to outer space. Can you believe it? Why? Well, it's all part of their Dream Big initiative to inspire people, especially students, to reach for the stars. On April 14, 2021, they launched almost 200 pieces of dinosaur bones into space using their new Shepard rocket. These bones are super old, like between 66 million and 70 million years old. They were fragments from a dinosaur called a Dromaeosaurus, which was part of a raptor family. It was kind of like a bird, but also a fierce hunter. It was about 7 feet long and had sharp claws on its feet. These guys were really good at hunting and slicing into their prey, you think? Can you imagine how cool it would be to see a real dinosaur like that? The bones were carefully packed into a small container that was about 4 inches long. Then, on April 14th, they launched into space on a test flight of Blue Origin's new Shepard rocket. The rocket went 65 miles above the ground, which is a little above the point where Earth ends and space begins. The dinosaur bones were in space for about 10 minutes and 10 seconds. Alongside them were more than 25,000 postcards from members of the Club for the Future, which is a special group that Blue Origin created to inspire future generations. There was also a test dummy named Mannequin Skywalker. on the flight to collect data. Once the dinosaur bones came back from their trip to space, they were put on display. Each of them was carefully placed and shown to people who are part of the Club for the Future, as well as in museums all around the country. But you know what's even more surprising? This wasn't the first time dinosaur bones went into space. In the past, NASA astronauts also took fossils on their mission. Back in 1985, a piece of a baby dinosaur's vertebrae and an eggshell flew on NASA's Space Shuttle Challenger. And in 1998, a 210-million-year-old skull went on to space on another shuttle called Endeavour. They must have had quite an adventure up there. I don't know, do fossils have fun anymore? Oh, and don't forget about the Tyrannosaurus rex. Yep, even parts of a T-Rex were sent into space in 2014 on NASA's Orion spacecraft. I bet those bones were really big and scary looking. But, surprisingly, this is not the only strange thing we've sent into space. In fact, a lot of our weird stuff has been there. For example, back in 2018, Elon Musk, the guy behind SpaceX and Tesla, did something totally wild. He sent his own shiny red Tesla Roadster into space. But that's not all. Inside the car, there was a dummy dressed in a spacesuit, and they named him Starman. How cool is that? Originally, the plan was to put the car in orbit around Mars, but something unexpected happened. The car went way past Mars and got stuck going around the Sun instead. Can you imagine driving a car around the Sun? It takes almost 560 days for the car to complete one lap. It's almost a 2-year-long trip. As of June 2023, they have completed more than 3.5 orbits around the Sun and have traveled over 2.5 billion miles. That's like going around the Earth over 100,000 times. The car has definitely gone above and beyond its normal driving limits. What's that they say about your mileage may vary? Unfortunately, Starman doesn't send us any new pictures anymore. It's been a while since we heard from him. Scientists think that both the car and the dummy passenger may have suffered some damage during their cosmic adventure. But, oh well, it was inevitable. It's space after all. Now, another strange thing that will be launched into space is the president's hair. Yep, you heard that right. On President's Day 2023, a company called Celestis made an unusual announcement. They're going to send some famous president's hair into outer space. Hair samples from George Washington, John Kennedy, Dwight Eisenhower, and Ronald Reagan were carefully collected and verified. This precious presidential hair will then be placed on the Enterprise spacecraft, which is going to launch from Cape Canaveral, Florida, sometime in the summer of 2023. But wait, that's not all. The spacecraft won't just carry president's hair. It will also have remains of other important people. One of them will be Gene Roddenberry, the creator of Star Trek. Some of his ashes were sent into space before, back in 1997, on Celestis' first flight. Well, I guess some of his remains still remain for a second trip. Now, here's the best part. The Enterprise spacecraft will not stay close to Earth. Oh no! It'll have a grander destination. It's set to travel beyond the farthest reaches of our solar system. It's going on an incredible journey into the unknown, from hair to eternity. Prices starting at $12,500 and up. But it's not as cool as a space party. Back in January 2018, something totally funky happened. Rocket Lab, an aerospace company, secretly sent a giant disco ball into space. They named it the Humanity Star, and boy, was it a sight to see. This massive mirror was about 3 feet wide and covered in 65 shiny panels. It spun rapidly as it orbited around our beautiful planet, reflecting sunlight back to Earth. It was so bright that you could even spot it without a telescope. The Humanity Star was like a dazzling reminder of how delicate and special our place in the universe is. But here's the sad part. The disco ball's time in space was short-lived. It came back down to Earth's atmosphere on March 22nd, just 2 months after it launched. That was way earlier than expected. Guess the party had to end sooner than they thought. Now here's a fun fact. Just like with dinosaurs, the Humanity Star wasn't the first disco ball to make its way into space. Starshine Project launched 3 similar shiny objects between 1999 and 2001. One of those groovy satellites, Starshine 3, stayed up in space for over a year. And let's not forget about Japan's mirror-covered satellite called Ajise, launched in 1986, which is still up there orbiting Earth today. Humans sure love to send disco balls into space, huh? Well, scientists also have a sense of humor. So, prepare for some interstellar monkey business. Sometimes astronauts like to dress up as animals while in space. Back in 2016, an astronaut named Mark Kelly had a hilarious plan. He smuggled a full-body gorilla suit to his twin brother Scott, who was staying on the International Space Station. Can you imagine a gorilla floating around in space? Well, it happened. There's even a video that went viral. Scott surprised another astronaut, Tim Peake, from the United Kingdom by chasing him through the different modules of the ISS while wearing the gorilla suit. And here's the twist. Tim Peake was actually in on the joke, so it was all a good-natured prank. Now here's a funny backstory. Mark Kelly had actually tried to send the gorilla suit to Scott in 2015. He hit it on a SpaceX Falcon 9 rocket, but sadly, the rocket went up in flames shortly after liftoff. Talk about bad luck for a gorilla suit. But do you know what item had better luck? The famous lightsaber from Star Wars, wielded by none other than Luke Skywalker himself. In 2007, a team of astronauts had a special mission. Alongside assembling the Harmony module on the International Space Station, they brought along Luke Skywalker's lightsaber. It was a tribute to the iconic movie series that inspired so many space lovers. The launch coincided with the 30th anniversary of the first Star Wars film, A New Hope. Fun fact, this lightsaber was Luke's second one, a cool green laser sword from Return of the Jedi. So these are the weirdest things we've sent into space. Next time you gaze up at the night sky, remember it's not just planets and stars out there. It's a cosmic playground filled with strange and wonderful objects from our very own Earth. And who knows what peculiar items will venture into space next?
The problem with that asteroid that destroyed dinosaurs was not that it fell, but where it fell. This colossal space rock found the worst place where it could land. Also, the angle at which it hit the ground was the most unfortunate. If it had fallen vertically, there would have been less destruction. But it fell at such an angle that it threw a huge amount of dust into the air. After the disaster occurred, tons of soot started burning. 65 million years ago, only 13% of Earth's surface contained the right amount of sulfur and oil needed to form a colossal amount of soot. If the asteroid had fallen on the other 87% of the territory, dinosaurs could still be living today, but it hit the worst place and lifted 1 million tons of burning material into the sky. A cloud of incandescent particles covered the sky and set off on a journey across the mainland. Then, these particles settled on the ground and caused large-scale fires. Trees were burning and sending more soot into the sky. But the asteroid collided not only with rocks, it fell on the coast in a place where the seabed was filled with sulfate. As a result of the collision, it started burning, which caused the release of sulfuric acid into the atmosphere. The air became poisoned. It seems the dinosaurs didn't stand a chance. And now, let's imagine the asteroid falling in another place, somewhere in the middle of the ocean. Huge waves flooded part of the land, but almost all kinds of dinosaurs survived. Or even better, the rock could have fallen somewhere in the desert and left behind a giant crater. That's all. Yes, several dinosaurs passing by wouldn't have survived the collision, but the situation wouldn't have been so critical in general. So, giant lizards remain dominant on our planet. They don't allow other animals to develop since Tyrannosaurus and other ferocious reptiles hunt mammoths and other ancient creatures. The population of mammals is decreasing. Velociraptors are fighting for territories with saber-toothed tigers and giant bears. A struggle for survival between dinosaurs and other animals begins. Then, the Ice Age comes, and some reptiles don't survive. Then, new players enter the field. Those are humans' early ancestors. Living side by side with dinosaurs is difficult. Lizards attack settlements and caves, so people have to build high walls for protection. By the way, the Tyrannosaurus poses less danger to people than you might have thought. According to the latest research, many creatures were able to run away from this monster. Yes, you probably saw how easily they caught up with cars in the movies, but it wouldn't be as scary in reality. Paleontologists and biologists have analyzed the strength of Dino's bones and found out that the creature couldn't reach high speeds. The maximum it was capable of was running twice as slow as a field athlete. Thousands of years have passed. People have learned to live with dinosaurs. They've even managed to tame some lizards. They've domesticated herbivorous dinosaurs to develop agriculture. Triceratopses and bulls now plow fields together. Imagine farms swarming with diplodocuses or brachiosauruses. People climb their long necks and pick fruit from high trees. Stegosauruses protect pastures from wolves and velociraptors. Dinosaurs with shells, such as ankylosauruses, help people cross deserts. They, along with camels and donkeys, carry heavy loads. People share the planet with ancient lizards and live in harmony. The situation in the seas and oceans is much worse. Sea reptiles attack wooden ships and catch all the fish. Imagine that you're sailing to another continent with tons of grain, fabrics, fur, and other goods. And then a giant mosasaur appears on the horizon. It's one of the most powerful sea lizards. A great white shark looks like a small fish next to it. The creature could easily defeat a megalodon. And then it comes across a wooden ship. It bites into the deck and pulls the whole boat underwater. Water dinosaurs are the main obstacle to communication between countries. This slows the progress down for 100 years. People built metal ships to withstand the attacks of the mosasaur. And finally, they managed to establish sea connections. A similar problem occurs when the first planes take off into the sky. Imagine you're flying on a passenger Boeing. You look out of the window and see a pterodactyl. Ah, wait, it's impossible. These winged lizards aren't so fast, but they can catch up with a helicopter or some old biplanes. This poses a serious threat to flights, so people install sound protection systems on board each aircraft. Pterodactyls hear irritating ultrasound from a distance and fly as far away from it as possible. People equip submarines and ships with the same sound shields. Then, after people have learned how to defend themselves from dinosaurs, another problem appears. Lizards are the kings of wildlife, so they displace all other animal species. Dinosaurs run across African savannas, and lizards with fur live in cold winter forests. Lions, wolves, and bears are not the rulers of the wild. Rhinos fight with Parasaurolophuses. Stegosauruses attack hippos and take away their territories. Venomous dinosaurs live in jungles. Lizards that can climb trees scare monkeys. Imagine a reptilian ape jumping from one branch to another. To save regular animals from extinction, people have to control the population of predatory reptiles. Huge parks and nature reserves appear in all countries. People transport dinosaurs there and separate them from other wildlife. Dinosaurs seem to be completely under control. When the danger caused by giant reptiles passes, people begin to breed smaller, harmless lizards. Someone buys a chameleon, and someone keeps a Microceratus at home. There are dinosaur exhibitions. People take these creatures for a walk as if they were dogs. Some people take selfies with reptiles, go shopping, and sit in cafes with small lizards. Dinosaurs aren't formidable now. They're kinda cute. People ride horses, camels, Parasaurolophuses, and Pachycephalosauruses. Of course, many have tried to tame velociraptors, but failed. Those are dangerous reptiles and they don't know how to obey. Taming them is almost as difficult as taming an alligator. But dogs and cats are still more popular because they're more intelligent. The brain of a dinosaur is almost the same as that of a chicken. But who knows, if they had lived to this day, perhaps they would have evolved into smarter creatures. Just imagine if dinos were intelligent. In this case, people would have a big problem. Some scientists think that even if a meteorite hadn't destroyed the dinosaurs, they wouldn't have survived to this day. They needed to carry their own colossal weight at all times. It was an enormous load on their bones and joints. Most dinosaurs wouldn't have been able to survive the Ice Age with such characteristics, but smaller lizards might have succeeded. Fast and agile dinosaurs, such as velociraptors and Pachycephalosauruses, would have survived, but in what form? Could dinosaurs have already evolved into something else? Look at the good old chicken. Many scientists believe it's a direct descendant of the formidable Tyrannosaurus. Somewhere deep inside the bird's DNA, there are genes that the dinosaur had. Yep, it's hard to believe, but look at the chicken's body structure and how it walks. Remove the plumage, cover the creature with scales, and give it toothy jaws instead of a beak. And now, you have a mini T-Rex in the coop. And by the way, not only chickens might be the relatives of giant lizards, many birds are dinosaurs' living descendants. Surprisingly, alligators, snakes, crocodiles, and monitor lizards are not as close to ancient reptiles as pelicans, storks, and other flying creatures. Over millions of years of evolution, the paws of dinosaurs turned into wings, and toothy elongated jaws ended up as beaks. The genetics of birds is the key to understanding dinosaurs. Pelicans are similar to pterodactyls, ostriches to velociraptors. Perhaps many other animals also share some genes with ancient lizards. If the meteorite hadn't fallen, all dinosaurs would have evolved into completely different, unusual creatures. Scientists want to carefully study the DNA of birds and try to reverse evolution with the help of genetic engineering. They hope to breed dinosaurs out of eggs one day. But to do this, they need to find a specific genome that hasn't changed over tens of millions of years. It hides in the DNA. And it's not so easy to find it and extract it. Do you think we will see powerful reptiles by 2050? We've all been afraid of the dark at some point in our lives, haven't we? I mean, do you remember getting tucked into bed by your mom or dad after they read you some scary fairy tale with monsters and dragons, or even dinosaurs? But just as your parents were about to turn the lights off and silently step out of your room, you remembered. What if there was something hiding under your bed? Or worse, what if some spooky creature was stuck somewhere in the closet? You could probably get up and check, but it was too dark out there. Wouldn't it be great to have some source of light that would come from within your body? You could always use it whenever you get surrounded by darkness. Unfortunately, as humans, we aren't able to do that. But there are a bunch of creatures out there that can, in fact, light themselves up. That's thanks to a little something scientists call bioluminescence. Animals and fish living in the ocean tend to have this talent more often than others. And you can find these creatures anywhere, close to the surface or deep down at the bottom. 2.5 miles deep if you have a knack for numbers. These creatures use their light for a lot of things, like communicating with other members of their species, luring in prey, and even scaring away enemies. Bioluminescence is basically an organism's ability to emit its own light. Chemistry has a lot to do with it. Such animals use two chemicals, one called luciferin and the other called luciferase. Add a bit of oxygen and bam! Light! Should you ever wonder if you actually observe bioluminescence or if someone just dropped a glow stick in the ocean, be on the lookout for neon blue, green, or even red sparkles in the sea. They're usually spread over a large area. This can even make the water look like glitter or a starry sky. You can thank squid, tiny crustaceans, and algae for this romantic atmosphere. Now, I've got another unusual phenomenon for you. How about a golden waterfall? I'm not kidding, it actually exists, and it's a natural phenomenon. To see it, you have to drive to Yosemite National Park to the Horsetail Fall. Make sure to plan your trip in winter or early spring. That's the only time during the year when you can see this awesome phenomenon. It doesn't need any scientific explanation. It's nothing more than sunlight at dusk hitting the waterfall in such a unique way that it makes it look like a river of lava. Or gold, your choice. That's the reason why during this time of year, the Horsetail Fall is also named the Fire Fall. Unfortunately, this phenomenon is becoming less and less visible within the years, mostly because of drought and other issues connecting with the melting of snow. So, should you ever decide to visit, keep an eye on the waterfall since the effect is very brief. Ever heard of a dirty thunderstorm? It's also called volcanic lightning. Apparently, specialists looking into the phenomenon have yet to fully grasp what it is. When a regular thunderstorm happens, particles with positive and negative charges collide, hence the giant spark we call lightning. It also makes a lot of noise, which you can recognize as thunder. But when a volcano is erupting, some of the volcanic ash particles get electrically charged, and while getting projected into the air with a huge force, they collide and cause electrical discharges. This whole process makes it look like there's lightning coming from the volcano itself. Imagine all that ash, gas, and smoke coming from the crater, and then add some electricity to the mix. It'll make the whole picture look really bizarre. No wonder this phenomenon is called the dirty thunderstorm. Now, how about clouds that look like waves? Those are called asperitas clouds, and they're actually quite close to the ground, unlike your regular day-to-day clouds. The name comes from the word aspero, which in Latin translates to rough or uneven. On rare occasion, you may spot such clouds when the weather is calm, but they're mostly associated with thunderstorms. These clouds appear during unstable atmospheric conditions, and surprisingly, they don't produce rain. Even though they do resemble dark storm-like clouds, they also create random patterns, tricking your eyes into thinking you're looking at the surface of the sea from under the water. Another impressive kind of cloud is called mammatus clouds. What makes them so special is a series of bulges emerging from the base of each cloud. One such cloud enters a level in the atmosphere where the wind direction changes. You can see these wave-like patterns in the sky. Australia is the place for you if you like surfing, but not all the waves you can catch there are made of water. Near a town called Hayden, there's a mysterious wave made out of rocks. This granite formation supposedly dates back to 2.63 billion years ago. That's way before dinosaurs started hanging around the planet. Standing at 49 feet high and 360 feet long, the wave was formed as a result of two processes: weathering and erosion. There's softer sediment at the base of the wave rock, which was chemically weathered by groundwater. Winds and rain did the rest of the job, causing the erosion of the rest of the formation. Its red, yellow, and gray stripes are made of iron hydroxide, carbonates, and other chemical compounds that were washed down by the rain. You've made it to Australia, so stick around a bit more. There's one more location here that seems unreal. You'll need to fly over this one, however, if you want the best picture. In the western part of the country, surrounded by green woodlands, there's a series of lakes. They're all a staggering shade of bright pink. Out of them all, the most famous is Lake Hillier, a 2,000-foot-long reservoir. It's surrounded by both sand and a forest of eucalyptus trees. This makes the cartoon-like hue of the lake stand out even more. One of the many theories explaining the color of these mysterious lakes is connected with algae. These algae appear to gather high levels of a substance called beta-carotene, which has a red-orange pigment in it. Another explanation involves haloarchaea. Those are microorganisms that sometimes look red. Even if you don't enjoy flying, the lakes are great for taking a swim. They're not toxic, even though they have loads of salt in them. This means you'll be able to stay afloat easily, and the water won't damage your swimsuit. During winter up north in Canada, a bizarre phenomenon happens at Lake Abraham in Alberta. Underneath the frozen surface, you can spot some weird objects that look like frozen jellyfish. It's definitely not the case, as these creepy formations are just frozen methane bubbles. Those are pockets of gas that were trapped underwater and got stuck there after the lake had frozen. They appear when leaves and grass fall into the water and bacteria digest them. This process transforms them into methane. This phenomenon is as beautiful and strange as it is dangerous. The pockets of methane can easily become highly flammable. When the temperatures rise during the spring, the ice melts and these bubbles start popping and fizzing. It's a spectacular sight to observe. Picture a lake filled with soda. Remember not to bring any source of fire. It can be very dangerous for visitors. You can check out these types of lakes all across Canada's Banff National Park. Nature often tends to make its own music. Just listen to the sound of crickets at night, or the soothing noise of a waterfall. But in Bucks County, Pennsylvania, there's a strange geological phenomenon which takes nature soundtracks to a completely different level. These are called the ringing rocks, and scientists still can't explain their unusual behavior. If you strike these rocks with a heavy object, like a hammer or another rock, the stones will make a ringing sound, as if they were hollow, but they're not. What makes the ringing rocks even more bizarre, apart from the mysterious sound they make, is that no animal wants to hang around there. Even though the rocks are surrounded by a thick forest, scientists haven't managed to trace any animal activity in the area yet. Even more striking is the fact that despite all the trees around the rocks, you won't find any leaves lying on the boulders. What makes these rocks so unappealing for both animals and vegetation is still up for debate.
It's normal for planets to be a bit tilted on the side. The Earth is tilted at a 23-degree angle. That's why we have seasons. It's summer when the part of the world where you are leans closer to the sun. It works the opposite way too. It's winter when you lean away from it. But Uranus is tilted more than normal. It lies as a 98-degree angle, which has a huge effect on its seasons. Each season on Uranus takes 21 years to play out. Something to think about the next time we complain that winter lasts forever. Now, here on Earth, we measure distances in minutes and hours, maybe even days. It takes 10 minutes to walk to your best friend's house, or 15 minutes to drive to your favorite cafe. But in space, it's different. It's vast, which means we measure how long it takes to get to a certain point in years, or in most cases, light years. So, if you want to walk to the moon one day, that would take you 9 years to span the 239,000 miles. Perhaps you'd like to take a ride to the nearby star, Proxima Centauri. Maybe if you kept the pedal to the metal at a constant speed of 70 miles per hour, you'd get there in about 356 billion hours, or around 40.5 million years. Trust me, after the first 20 million years, you'd be second-guessing yourself as to why go there in the first place. Now, Mars contains the biggest valley, Valles Marineris, we've discovered so far. It's a pretty impressive system of canyons, 2,500 miles long. That's 5 times longer than the Grand Canyon. Researchers first spotted it back in the 1970s. A bank of volcanoes located on the other side of the canyon ridge probably helped form this valley. We haven't discovered a planet completely made of diamonds yet, but on some planets, it actually rains diamonds. On Jupiter and Saturn, gas giants of our solar system, lightning storms turn abundant methane into soot, which we also know as carbon. The soot falls and transforms into graphite. Further graphite transforms into diamonds with a diameter of about 0.4 inches. Now, before you start figuring out how to book a diamond collecting field trip, know that these diamonds don't last. After they enter the planet's core, they melt. Ever notice how when you're stargazing 2 nights in a row in the same time, let's say 9 p.m., the stars stay in the same place, but the moon doesn't? Well, there are 2 reasons for that. First, it depends on what time you go stargazing. For instance, if you go outside at 8 p.m. and tomorrow you look for it at 11 p.m., you'll see the moon in 2 pretty different places. In this case, even the stars take different places in the sky since our planet is spinning. As you know, it takes 24 hours for it to make one full circle. That means, from our point of view, it seems like both the sky and everything up there is just moving around us one time per 24 hours. In the same way, the sun changes its position, rising and setting every day. So, if you went outside 2 nights in a row at the same hour, in most cases, you'll have to wait for an extra half hour or more until the moon gets back to the same position as the night before. The stars are pretty much standing still. It seems like they're moving, but that's because the Earth is spinning. But the moon is actually moving around our planet and goes through different phases. For example, a new moon is when it's completely dark in the sky. A full moon is when its day side is facing the Earth. It takes approximately a month for it to finish one circle around the Earth. Maybe you'd be luckier on a diamond collecting expedition on this next planet, 40 million light-years away from Earth. Scientists used to call it a super-Earth. Now, a super-Earth is generally a planet way bigger than ours. This planet, for example, is double the Earth's size. It's so close to its star that it makes a full circle around it in less than 18 hours, which means a year there is pretty short. Since it's so close to its star, its temperature goes up a whopping 4,900 degrees Fahrenheit. Because of the heat, in combination with the planet's density, scientists have the theory that its core is made of carbon in the form of graphite and diamonds. Over 10 years ago, astronomers discovered a huge water vapor cloud. It was 12 billion light-years from our home planet. That cloud is the biggest source of water we know of. It's also the oldest, dating back to when the universe was only 1.6 billion years old. Now it's 13.8 billion years old. Man, if only I had started a savings account 12 billion years ago. With compound interest, I'd have me quite a pile of cash by now, but I wasn't around then. Anyway, this cloud is so large it holds 140 trillion times the amount of water in all the oceans on our planet. This cloud kind of feeds a black hole. It may also contain enough gases, such as carbon monoxide, to encourage the black hole to grow 6 times bigger than it is at the moment. The average temperature of our planet is about 57 degrees Fahrenheit, and the highest temperature ever measured was 134 degrees. Sound too hot? Well, on Venus, it can go up to 900 degrees, which makes it the hottest planet in our solar system. It's not hot enough to melt steel, though. It would need to be higher by 2,500 degrees to get there. But it's hot enough to melt lead, and it's way too hot to sustain life, at least not in any form that we know. Venus is not even the closest to the Sun, it's Mercury, but it has a super thick atmosphere that traps greenhouse gases. It's like you covering yourself with a pretty thick blanket in the middle of the summer. Now, we're used to seeing volcanoes spewing hot molten lava. After all, that's what they mostly do on Earth. But in space, volcanoes tend to spew methane, water, or ammonia. And these materials freeze as they erupt and eventually transform into frozen vapor and something called volcanic snow. I'm talking about cryovolcanoes here. You can find them on Jupiter's moons Io and Europa, Saturn's moon Titan, and Pluto. These volcanoes are especially active on Io, which has hundreds of vents. NASA vehicles have even captured some of these erupting in real time. Plumes of frozen vapor coming out of them extended for about 250 miles. Hey, by the way, they just discovered another moon around Jupiter that might actually be good for farming someday. It's named EIEIO. Now, what exactly happens to the light after it disappears inside of a black hole? Well, photon is a particle of light. The event horizon is the boundary of a black hole. When something, say a photon, crosses the line and enters those boundaries, it can't escape anymore. But it doesn't mean a black hole destroyed it. It pulls the photon in rapidly towards its center, where an enormous mass is packed into an infinitely small space. But we're not sure what happens to photons in such extreme conditions. It's still one of the biggest mysteries. Does a black hole destroy the light or not? Saturn has 82 moons we know about. 53 confirmed and 29 more that are still on the waiting list to be confirmed as actual moons before they get their official names. And one of the coolest moons might be a 914-mile-wide hunk of rock called Iapetus. It's dark on one side and bright on the other. Its lighter half is 20 times more reflective than the other one. As it turned out, the bright side is ice. The dark side is a bit more complicated. One theory says it's dark because of particles coming from another moon, the one named Phoebe. Another theory says it could be because of heat. Since the moon is rotating really slowly, its dark material is absorbing heat, which makes it even darker. Now, how big do you think a black hole can become? In theory, we can't find an upper limit to its mass, but astronomers believe the ultramassive black holes, or UMBHs, located in the cores of certain galaxies are mostly up to 10 billion solar masses big. Recently, they even discovered these UMBHs physically can't grow much more than this, because, in that case, they would start to disrupt the accretion disks that feed them. That way, they would kind of stuff the source of new material. Most people picture the universe as somewhere between aquamarine and pale turquoise. Even some researchers thought that was the case. They managed to determine the cosmic color by combining light from more than 200,000 galaxies within 2 billion light-years of our planet. But the real color is actually closer to beige. Researchers got it all wrong because there was a bug in the software. No, really? It converted the cosmic spectrum into the color our eyes would see if we were exposed to it. The team defined this color as a cosmic latte. Ooh, make that a double-shot low-fat large to go, please.
People stop their cars on the highway, get out of them, and lift their heads in wonder. In the cities, everyone takes to the streets. Balconies and rooftops of houses are full of people staring at the moon in shock. It's red. Some people scream that it's the end of the world. Some seek shelter. Indeed, the usual white moon now looks like it's been doused in red paint. There's no need to be afraid if you see such a thing. On the contrary, enjoy the view, because you have witnessed a rare astronomical phenomenon. This is a total lunar eclipse. Here's the sun. It's in the center of our solar system. Mercury, Venus, and here's Earth and the moon. The Earth takes 365 days to orbit around the star. At the same time, the moon revolves around the Earth and completely orbits our planet in 27 days. The Earth creates a shadow zone, and sometimes the moon passes through it. The shadow is cone-shaped and gradually narrows. The moon is 238,000 miles away. That's like 9 lengths of the equator. At this distance, the width of the shadow is about 2.6 times the width of the moon. When the moon is in this zone, direct sunlight doesn't reach it. That is, it should have disappeared, but instead, it becomes red. All because the sun's rays pass through the Earth's atmosphere. They scatter, and most of the blue light disappears. But the red and orange rays continue and hit the surface of the moon. Voila! You see a phenomenon called the blood moon. By the way, this curvature of light occurs at sunsets and dawns. The atmosphere scatters the blue light, and you see a red and orange sky. If you were standing on the surface of the moon during a total lunar eclipse, planet Earth would be exactly between you and the sun. So you would be able to observe the solar eclipse. The surface of the Earth would become entirely dark for you. All you'd see would be the sun's corona illuminating the edges of the planet. The Earth from the surface of the moon is almost the same size as the moon from the surface of the Earth. Such a red eclipse of the moon is rare because several factors must coincide. One of them is that the moon must be full. Usually, you can see 2 total lunar eclipses a year. In 2038, you'll be able to see 4 such eclipses, and the eclipse itself can last up to 108 minutes. But this is rare, and the last time such a long blood moon was seen was in 2000. Many years ago, people didn't know so many facts about our satellite, and the sight of a red moon frightened them. It was a bad sign and a harbinger of trouble. People who knew the schedule of eclipses could take advantage of it. For example, Christopher Columbus had an astronomical almanac and knew when the next lunar eclipse would occur. He frightened the inhabitants of the Caribbean islands when he predicted the red moon. Once upon a time, the moon used to be a red ball of lava. This was way back in time, 4.5 billion years ago. Now this is our solar system. It's full of dust and asteroids. They're constantly bumping into each other, playing space billiards. This is Earth. It's just beginning to cool off from the constant asteroid and comet impacts. But then, Theia appears on the horizon, a planet the size of Mars. It had a chaotic orbit and was approaching Earth in a spiral. A collision was inevitable, and at one point, one of the biggest crashes in our solar system occurred. Theia struck the Earth at an angle. It ripped out part of the Earth's crust and threw it into space. The Earth, in turn, absorbed part of the planet that rammed it. The debris from the collision circled the Earth for a long time. They were a kind of ring, almost like Saturn's. Debris in orbit collided and piled up around a common center of gravity. And that's how the Earth got the moon. There's a theory that this collision helped give birth to life on our planet. Theia hit the Earth at a perfect angle. If the crash had been head-on, both planets would likely have been destroyed in a massive explosion. If the impact had been tangential, then there wouldn't have been enough debris in Earth's orbit to form the moon. But we got the lucky ticket. The moon stabilized the Earth's rotation. The collision shattered the planet's solid crust and allowed oceans to form. Remember, water is the basis of life. When the cores of Earth and Theia merged, we got a powerful magnetosphere. This protects all living organisms from solar radiation. The moon, along with the sun, controls the tides.
Its gravity seems to draw water to it from the Earth's surface. The Sun does the same thing. That is, if we imagine the Earth as a ball of water, there would be two mountains, one on the Moon's side and one on the Sun's side. And as the Moon moves around the Earth, this mountain of water moves with it. If you were in the open ocean with a tape measure, you would see that the Moon is attracting water to itself by about 4 to 6 inches. The Moon is gravitationally locked with the Earth. That's why it's always turned to us with one side, like Mercury and the Sun. But the Moon doesn't stand still. It's gradually moving away from our planet, about 1.5 inches a year. Not quickly, but in about 600 million years, it will have shrunk in our sky so much that we won't be able to see lunar eclipses anymore. Do you see this crater? It's Tycho. It's visible during a full moon because of these bright rays that extend thousands of miles from its epicenter. This is the youngest crater on the Moon. Scientists say it appeared there due to a meteorite impact about 109 million years ago. At that time, dinosaurs were roaming the surface of our planet, and they may have seen the impact. It was most likely accompanied by a big explosion and looked like a salute in the night sky. Humanity loves to explore the Moon. We've sent a bunch of missions there. A total of 12 people have set foot on the surface of the Moon. The gravitational force there is 6 times less than on Earth. So, if the average person on our planet weighed about 180 pounds, on the surface of the Moon, the scales would only show 30 pounds, like the weight of an average dog. That's why the astronauts moved, jumped, and fell so strangely there. And you would be 6 times stronger on the surface of the Moon. Here on Earth, the average person could lift about 130 pounds, but on the Moon, you could raise a big motorcycle or a grizzly bear. The surface of the Moon is covered with regolith. This is the lunar dust that covers the solid ground. Such dust is good at preserving footprints. Here's the most famous footprint, which gave birth to many crazy theories. Here's the footprint, and here's the shoe that left it. But the shoe is completely flat. This is explained simply. The astronauts wore extra boots for walking on the lunar surface. They have exactly the kind of sole that left these marks. In addition to the footprints, we left many fascinating objects on the Moon. Several lunar rovers, a golf ball, flags, and human waste. There's also a lot of broken satellites and rocket parts. All in all, about 413,000 pounds of human-made objects are there. That's the weight of 3 passenger planes, or 31 adult elephants. In the future, we plan to resume missions to the Moon. New landers will explore the surface of our satellite to find natural resources there. It's also a great place to test new rovers. We're even going to build something like the International Space Station in the Moon's orbit, the Lunar Orbital Platform Gateway. It'll be a convenient platform for exploring our satellite and launching spacecraft into distant space. If you start from here, the spacecraft won't need to spend almost all its fuel to overcome the force of Earth's gravity. So, such a station would save fuel and money. Scientists hope that we'll be able to mine water from the Moon's surface. It's been proven that there's ice there, mostly at the bottom of craters where the sunlight doesn't reach. Perhaps we'll send a rover there that can drill down a few feet into the surface, searching for water. Humanity already has the technology to build a full-fledged colony there. It would take up to 3 days to get there. We just need to get enough solar panels and building materials to the Moon. There's no atmosphere on the Moon, so potential lunar inhabitants would be defenseless against solar radiation. We would have to build houses underground to provide protection. Modern 3D printers will help make construction easy and fast. However, food and water supplies can only be maintained by constant supplies from Earth. The same goes for oxygen. Each rocket launch costs millions of dollars, so for now, colonization of the Moon is in question. The Moon could also become an object for space tourism. Imagine a spaceship launches from Earth, 3 days on the road, and you're orbiting the Moon. The lunar module undocks, and you land on the surface. You ride the rover, explore the craters, then return to the lander. The engines start, the lander returns you to orbit. You dock with the ship and return to Earth. Sounds like some pretty great plans for a week's vacation.
Now, you wake up one morning and watch the news while having your morning coffee. They did it again! Those scientists! The news anchor yells on the TV. A report was released a few days ago that the Moon is moving further away from Earth's orbit. Its distance extends 2 inches per year. Over the past 2,000 years, it's drifted a total of 260 feet. This isn't too daunting of a distance, but the news has still made people panicked and concerned. They rally together around the planet, uniting to try and stop the Moon from escaping Earth's orbit, even though it won't actually leave the orbit for over 1 billion years. But everyone was focused on the past benefits of the Moon. It's obvious life on Earth as we know it wouldn't have evolved without its existence. The Moon is controlling the tides and the molecules in the atmosphere. Without it, humans, in particular, wouldn't have evolved. So, with an appreciation of the Moon, the top brass ordered the best scientists to come up with a solution to push the Moon closer towards the Earth. A giant thruster engine was built on the dark side of the Moon. It was ignited, and the thrusts tried to push forward, but the startup power wasn't strong enough to push the Moon. Instead, it tilted the Moon's axis, rotating it slowly. As the Moon rotated, the scientists hurried to turn it off before the engine reached its full power, as it was headed off course. The brass didn't accept this and ordered them to continue with the objective. The scientists insisted the math wasn't correct and didn't know exactly what may occur. Their concerns were ignored, and they watched as the engine's power increased. The engine slowly pushed the Moon, the distance reducing. But as it was provided at the wrong moment, the angle it was aimed at would provide complications. The thrust and gravity from the Earth ensured the Moon followed the orbit at a reduced distance. But with the combination of the initial thrust on an indirect angle, the Moon was directed away from the Earth, quickly moving further off its trajectory on a path to leave the orbit altogether. As you finish your breakfast and turn the TV off, you go outside to look at the Moon. It sits high above, seemingly fine. Surely, the news anchor was just exaggerating. You go to work. The issues of the Moon are now just an afterthought. Even if it was true, how could it possibly affect your day? The morning feels normal, just another day at the office, as it turns out. During your lunch break, you head into town and notice on your way that the wind is picking up, getting stronger and colder. It must be a storm approaching. You quickly check on the Moon. It appears smaller, about half the size of what it was this morning. But it's midday, so it's supposed to be that size, isn't it? After you finish your meal at the restaurant, you leave to find it's becoming darker. The wind is much stronger than earlier, but there are no storm clouds in the sky. People in the streets are pointing towards the sky, shocked at something, probably an eclipse. As people begin running in the streets frantically, you look above and can't see the Moon. Confused by everything, you decide to head home for the day. When you arrive home, you turn on the TV. The news anchor, who is now more serious than earlier, explains that the Moon has left the Earth's orbit altogether and is flying off somewhere into space. The loss of the Moon means the daily cycle has changed. Now, there are only 6 to 12 hours of sunlight a day and over 1,000 days per year. I only have to work half as much, you say excitedly, pumping your arms in the air. The lack of the Moon creates a completely different world. The pull of the Moon's gravity is what keeps the Earth in a place at 23.5 degrees angle, ensuring the weather patterns and normal days that we're accustomed to. Baffled by all the scientific information, you go outside to just confirm you aren't being pranked. The shorter working week seems too good to be true. As you look out into the sky, you notice the stars are brighter than you have ever seen. You can clearly see the outline of the Milky Way's arms. The stars are far more numerous than you remember, with Venus glowing far brighter than them all. It's a beautiful sight, but you're not sure whether a clearer night sky was worth the Moon's removal. You have never been interested in astronomy. You decide to go to bed. It's a good idea to adjust to the new night and day cycle. You set your alarm for 2 hours. That should be enough, you say to yourself happily. Tomorrow is Saturday, after all. You need to get up early to go surfing. Gotta catch those high tide waves. You wake up, get your things together, and drive to the beach. The news on the radio explains some issues about how the Earth is now more defenseless to asteroids without the moon. Then they talk about some issues with the tides. Something about how the tide is now 1/3 the size it used to be before. You're unsure how this could affect the waves. Maybe it means they will be larger. You park at the beach, grab your board, and look towards where the surf should be. It should be high tide, but the sea is somehow a lot further away than normal. You shrug off the hurdle of having to walk towards the water. After a long, enthusiastic walk toward the gnarly waves, your mood changes as you approach, staring blankly at the tiny waves. Upset, you head home. While driving, you listen to the news and pay more attention to the information provided. In place of structured seasons, there are only erratic weather patterns. Winds are faster and stronger, creating more powerful storms, and in some places, there are just stagnant conditions. The equator is no longer always warm. The poles aren't constantly cold. The depths of water shrink. Tides only adjust to the sun's gravity, reduced to 1/3 of the pre-moon depths. Throughout the world, the seas change in altitude, shrinking at the poles, and the bulge of water around the equator shifts. The moon regulated the tides and provided the periodic changes that were a key element to assisting with life on Earth. Aquatic life forms are displaced within shallows worldwide. Life cycles of important microbial life have been upset. You couldn't imagine that something as simple as a change in the tides could be so important to billions of life forms. Water and precipitation, which is distributed across the globe, cannot provide sustenance where they did before. The weather has become more extreme, hotter for longer periods and colder for other parts of the Earth. Over time, some thousands of years in the future, dry deserts will transition into ice ages. These intense changes disrupt the natural order of all things for life on Earth. Not only did the moon control the tides and weather, but it used to pull molecules within the atmosphere as it moved. The now constant movement disrupts molecules, creating barriers for future evolution. You arrive home, upset after learning the disheartening news. Not only will you never be able to surf again, but all life on Earth will change. An age of devolution has begun. Over the next year, flora and fauna changed to adjust to this new world. Migratory animals that would travel toward greener pastures find nothing at all. Birds are completely confused, with no end to the change in seasons. Hibernating animals delve in and out of their shelters at the incorrect times, and vegetation struggles to grow at the lack of sunlight. Nocturnal animals cannot see without guided assistance from the reflection of the moon. Although Venus is the brightest source of light when it's dark, it's only 1/1000th of a fraction as bright as the moon was. Predatory animals that hunt during the night are not capable of finding their prey, providing an opportunity for smaller animals to thrive. Although life on Earth has changed, it will continue to exist. But the sudden adjustments will become a test for all walks of life. Over time, it will be very interesting to see what species have adapted and evolved. A world where rats and mice would be more prominent due to their adaptive capabilities could create a new dominant species to emerge. In millions of years of evolution, their descendants will primarily flourish. We could see buffalo-sized mouse herbivores crossing the plains and tiger-sized rats roaming within the jungles. Tree-faring mice with long arms may swing amongst the branches. Others will probably move to the seas in place of mammals to feed upon aquatic life. Wide-eyed predatory rats may occur to have similar traits to bats, with echolocation, becoming the conquerors of pitch-black nights. All the new species that will emerge, undoubtedly, will continue to be monitored by humans, wherever we may be.
Have you ever wondered why Earth doesn't have rings? gas giants, Jupiter, Saturn, Uranus, and Neptune, have them. But the rocky planets, Mercury, Venus, Earth, and Mars, don't. Two theories describe how ring systems potentially developed. The first one says that rings may have formed from leftovers that date from the time a certain planet was forming. Or, as the second one says, they could be the remains of a moon that was either destroyed in a collision or broken apart by the gravitational pull of its parent planet. Scientists still don't know why the gas giants have rings, but they think it could be because they formed in the outer solar system. Rocky planets formed in the inner area of our solar system, which is why they were more protected from potential impacts and collisions that might have formed rings around them. Or the reason is that the bigger planets have a larger volume, which allows a ring system to remain stable. Some scientists think our planet did have a ring system a long time ago. In its early stage, a Mars-sized object hit the Earth, and this probably resulted in a dense ring of debris. But its ring system pretty soon coalesced, and that's the way our moon was formed. More than 10 years ago, in 2011, astronomers found a huge water vapor cloud about 12 billion light-years away from our planet. This cloud is the oldest source of water that we know of. It dates back to when the universe was only 1.6 billion years old, and now it's 13.8 billion years old. This unusual cloud is also the biggest source of water that we know of. It holds 140 trillion times the amount of water that the Earth contains in all its oceans. Enormous. The cool thing is, this vapor cloud is kind of feeding a black hole. It may contain enough gases, such as carbon monoxide, to help its black hole grow even 6 times bigger than it is now. We all know that Earth has one moon, but there are 2 more asteroids, 3753 Carina and 2002 AA29, locked into co-orbital orbits with our planet. The first one doesn't really circle around the Earth, but has some sort of a synchronized orbit with the planet, which is why it looks like it's following the Earth in a stable orbit, while in reality, it has its own specific path around the Sun. The other one, 2002 AA29, follows a horseshoe orbit around our planet. Its specific path brings the asteroid closer to us every 95 years. You'd expect Neptune to be an extremely cold and dark place. After all, it's an ice giant 2.8 billion miles away from the Sun. There's not too much sunlight there. So noon on Neptune is similar to twilight on our planet. But this ice giant appears to be creating its own heat. To be precise, 2.6 times more heat than it gets from the Sun. This probably has to do with all the pressure near the planet's core. It builds and releases hydrogen, which keeps Neptune's center at a crazy temperature of 9,300 degrees Fahrenheit. But its atmosphere is still quite chilly. It ranges from about negative 240 degrees Fahrenheit to negative 330 degrees Fahrenheit. What shape do you think of when someone mentions storms? Probably long ovals of hurricanes and conical tornadoes. But that's something we see on Earth. At Saturn's North Pole, a storm has been raging for at least the past 40 years, and it has a hexagonal shape. Such a weird shape probably has something to do with Saturn's turbulent gas, or maybe even with zonal jets that extend many miles down into a region of extremely high pressure. Have you ever wondered why planets don't twinkle while stars do? The thing is, if you were out there in space, you wouldn't see them twinkling at all. The reason we see stars twinkling is because of Earth's atmosphere. The pin-sized light coming from a star hits the atmosphere. The atmosphere then refracts it, which sends the light skittering off in a zigzag. That's what we perceive as the twinkle. Planets appear much bigger to us than just pinpoints. And yes, their light zigs and zags after hitting the atmosphere too. But those motions cancel each other out, which is why we don't see twinkling, but only a steady glow. In some regions, you can expect big changes in temperature. For example, in Montana, where in a single day, temperatures went from negative 54 degrees Fahrenheit to 45 degrees Fahrenheit. Yeah, sounds like a lot, but it's still nothing compared to Mercury, where temperatures tend to vary over 1,000 degrees Fahrenheit in a single day. They start out at negative 280 degrees Fahrenheit at night, and eventually go up to 800 degrees Fahrenheit during the daytime. Picture a wardrobe you'd need to prepare for a single 24-hour visit to Mercury. Why doesn't the atmosphere of our home planet vanish and disappear into the vacuum of space? Even though we can't see them, the gas and vapor molecules that our atmosphere consists of all have mass. As such, all of these molecules feel the gravitational pull of the Earth, just like we do. They could escape, true, if they had enough energy. For instance, if our planet was closer to the Sun, the atmosphere would be hotter, and its molecules could get away easier. But the Earth, fortunately, is just at the right distance from the Sun and has exactly enough mass to keep its atmosphere in the same place. When you think of volcanoes, you probably picture hot molten lava coming out of them. At least, that's how it works on Earth. But in space, volcanoes can spew methane, water, or even ammonia. Up there, a volcano can also spew specific materials that freeze as they erupt. Then they turn into frozen vapor and some sort of volcanic snow. It's a common thing on Jupiter's moons Europa and Io, also on Pluto and Saturn's moon Titan. They're called cryovolcanoes, and Io has extremely active ones. Over there, you'd see hundreds of vents with plumes of frozen vapor that tend to extend about 250 miles. And NASA vehicles have even captured some erupting in real time. Bam! Planets, moons, asteroids, comets, and stars, they can all collide, and galaxies too. Our galaxy, the Milky Way, is 2.5 million light-years away from Andromeda, our closest galactic neighbor. Astronomers believe the Milky Way is on a collision course that will destroy both galaxies in the distant future, or at least galaxies as we know them. The two galaxies are going faster and faster toward each other at a rapid clip, 250,000 miles per hour. It will be chaotic, and many planets and stars won't survive the collision. Eventually, these two massive entities will merge and turn into a completely new, unrecognizable galaxy. But here's a small comfort. Scientists assume this is not scheduled to happen for another 4 billion years. In case you want to fuse two pieces of metal together, you already know the only way to do that is to apply heat so these pieces can reach their melting points. In space, you don't need heat to do such a thing, or basically, any action at all. We call it cold welding, and such a phenomenon happens when you slide the metal pieces over each other. In that case, they wear away their protective oxide layers. On Earth, these layers stop them from fusing, but in space, this type of protection disappears. That's why the electrons from one piece of metal just flow into the other piece. And ta-da! They're one without any effort. Scientists used to believe the Earth was the only planet in our solar system with tectonic activity going on. Tectonically active means plates under the crust are moving. This process releases heat, which then deforms the Earth's surface and leads to its shrinking. But now, we know this happens on other planets too. Mercury is also shrinking, and scientists found it out in 2016 when the Messenger spacecraft orbited the planet and sent back some important data. It revealed that there were cliff-like landforms known as fault scarps on Mercury's surface. Since these landforms are relatively small, they probably didn't form that long ago. That means Mercury is still contracting, even 4.5 billion years after our solar system was formed. Jupiter's Great Red Spot is shrinking as well. It's a huge storm that rages on the planet's surface. It's reddish, a bit oval in shape, and more than 10,000 miles wide. Yep, that's big enough to swallow the Earth. And now, it's been slowly but surely shrinking for a couple of centuries. The Great Red Spot is just one of many high-pressure storms that occur across Jupiter due to all those gases present there, which is something that classifies Jupiter as a gas giant. But just because it's shrinking doesn't mean the Great Red Spot is going to blow itself out anytime soon. It's even growing taller. The space crew had been getting ready for the launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the moon on July 20th, 1969. Since then, the moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the Moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the moon. So, the Lunar Year 1, Day 1, began on July 21st, 1969 at 2:56:15 Universal Time. Since the moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the moon's poles, however, the temperature is always at around -400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the moon's existence influences us so. In the Middle Ages, scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions. Because they saw this inexplicable connection to the full moon, people with these symptoms were named lunatics, or at times, literally, moonsick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture. But scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our moon, and is called the South Pole Aitken. This giant formation is located on the far side of the moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the moon. Is something strange happening with our moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color depending on various phenomena. The moon seen near the horizon will most likely be yellow or red-tinted. The rarer blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, but what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project for example, scientists need to take this into consideration, not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission scheduled for May 2024. Artemis 3, 4, and 5 are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days.
Hey, you're running through a vast field at night, as if something is chasing you right now. The light of the full moon brightens your path, and you see a circle of light around it. You run on looking for a safe shelter. It's not about werewolves, who are said to appear when the moon is full. Soon, this place will be the epicenter of a major storm. This very circle around the moon is called a halo, and ice crystals cause it in the sky. When the moon is full, it reflects a lot of sunlight. These rays then pass to the Earth's surface, but they curve their trajectory and split as they pass through hexagonal ice crystals. As a result, we have a halo of different colors, almost like a rainbow. The inner edge of the halo is red and the outer edge is blue. It looks beautiful, but the presence of ice in the clouds means this ice will soon turn into water and begin to fall to the ground. And this rain will be so heavy that you'd better find a shelter beforehand. If the weather is quite warm and the clouds are closer to the ground, you might see a similar phenomenon, a corona. It's much smaller than a halo, but much more colorful. The bluish-white disk on the inside turns brownish-red on the outside. Unlike halo, the corona is made of water droplets. The smaller these drops are, the larger the corona will be. If the water droplets are large, the corona will look like a bright spot the size of the moon itself. Both the corona and halo might also occur during the day when the sun is shining. But be sure to wear sunglasses before just glancing at it because it's very bright and really bad for your eyes. As soon as you find a shelter, it starts raining heavily. Whoa, what is that? Are you being photographed? No, the flash you just saw is lightning. Bam! Thunder is so strong, the windows in the house start to shake. Here's a tip on how to tell if you're far away from the epicenter of a thunderstorm. When you see lightning, start counting. 1 1,000, 2 1,000, 3, and so on. When you hear the thunder, stop counting. Now you have to divide that number by 5. If you can count to 5, it means the epicenter of the thunderstorm is 1 mile away. If you didn't find a shelter before the thunderstorm started and it caught you in the open, leave the high ground immediately. Any mountain or hill is a high-risk area. Don't even think about hiding under a tree. Tall objects are the first target for lightning. Power poles are also at risk. If a thunderstorm catches you riding a bike, drop it immediately and run away. Same if you were riding in a convertible, golf cart, or motorcycle. If a thunderstorm started while you were in an open field, the tallest object here is you. Get down and try to cover yourself somehow. If you're not alone, try to keep your distance from each other. Whew! Now let's admire the beautiful sunrise. It looks like someone spilled red paint on the sky. This beautiful view means it's about to start raining. You can see a red sky at sunrise because the high-pressure zone has just passed you by and is now followed by a low-pressure zone with high water content in the air. So take an umbrella with you or go back to a warm bed and stay indoors. There's an old saying to keep it all straight. Red sky in the morning, sailor take warning. Red sky at night, sailor's delight. Sometimes you can even predict rain by smelling it. It's all about ozone molecules. Storm currents bring ozone down from the upper atmosphere, and when the storm is about to start, you can smell a sense of cleanliness. It's like you just washed the floor with clean water. Your sense of smell gets more sensitive before it starts to rain. It's not because of your nose, but because of the more humid air. Flowers spray their scent, and the water molecules stick to it, spreading it much better. That's why the same flowers smell different when you smell them outside or in a closed, humid greenhouse. Plants can also help you predict changes in weather. If you touch the grass in the morning and it's wet, it means it's going to be a clear day. That morning water on the grass is dew. It appears at the coldest time of night. Clear skies allow the earth to cool a bit, and the water vapor molecules in the air turn into a liquid that settles on various surfaces. Take a closer look at the leaves on the trees. Sometimes they can be upside down. For example, maple leaves respond well to increased humidity before the rain. Their stems become very soft, and the wind can turn them upside down. But the best indicator is pine cones. The seeds are inside the cone, just under its scales. The pine needs to keep them as dry as possible so that the wind can carry the seeds far away and new trees can emerge from them. So when the pine senses rain approaching, it gives the order to close the cones. Then the scales close, protecting the seeds from the water. And instead of boring weather forecast hosts, you can just follow the animals and insects. Have you heard the crickets chirp? That will be your thermometer for today. Set the timer for 15 seconds and count how many times crickets chirp. Add 37 to that number and you get the outdoor temperature value in Fahrenheit degrees. All because air temperature directly affects crickets' metabolism. It can chirp slower and faster depending on how warm it is. So throw away your thermometer and get yourself a little friend. Now, if you don't like insects, look up into the sky for birds. If they're flying high, it'll be a clear and sunny day. But before it rains, air pressure prevents birds from flying high. You may see them flying in flocks very low, most likely looking for shelter. So even if the sky is clear, air pressure tells you that rain is coming. If you live near a river or lake, you can hear toads singing, although you can't quite make out the lyrics because it's in toad. They are especially loud before it rains hard. Toads, in general, love wet weather, so they just get excited. Rain is also the best time for females to lay eggs, so they scream loudly in search of a guy to wed. Ow! A mosquito has just bitten you. If mosquitoes are being especially aggressive, you better find a shelter fast. The insects are just trying to eat more before they have to starve during the storm. Also, the warm, humid air makes us sweat more, and we become even more attractive to mosquitoes. Insects also gather in swarms before a thunderstorm. They love the moisture in the air and start circling in a dance. But then they vanish into thin air. It means you have 1 hour left before heavy rain starts. To predict the weather for the next day, you need to watch the bees. If it rains tomorrow, the bees work overtime. They're pollinating flowers actively because they know they won't be able to leave the hive the next day because of the rain. Squirrels can predict the weather for the whole season. They usually stock up on food for the cold times. And if they start doing it early, it's going to be a tough winter. You can see squirrels running around looking for acorns. They hide them in the ground and run to find the next one. The squirrels often forget where they hid the food. These acorns turn into little sprouts, so we have many new trees, all thanks to squirrels. Animals can also predict disasters like earthquakes. Scientists once did a study in an area with frequent earthquakes in Europe. They put trackers on cows, dogs, and sheep. About 18,000 earthquakes occurred there during that time. Most of them were insignificant, but there were also 12 with a magnitude of 4 on the Richter scale. And each time, before the earthquakes, researchers recorded strange animal behavior. It was as if they were trying to escape from the earthquake zone. Scientists believe animals can sense the ionization of the air before a disaster with their fur. Their good sense of smell also allows them to smell gas. It comes from moving deep underground and then trying to find its way out through small cracks in the surface. The first records of such animal behavior date back to ancient Greece. Cats, rats, snakes, and centipedes left their homes and fled to safety days before a major earthquake hit Greece. Some fish can predict the weather in the area. If sharks hang out near the shore, they're not necessarily looking for food. They may be hiding from a big storm at sea. The worst sign on the coastline is when all the water starts to go back abruptly. You can see the entire shoreline and even the fish and coral that are left on the land. Run away immediately, because soon a huge tsunami wave will come here and wash everything away.
About 8 billion inhabitants of planet Earth found out the same terrible news in one day. Someone saw it on TV. Others heard it on the phone while scrolling through social media or listening to music. Some witnessed this news in a dream while sleeping. Someone's voice said it in all languages to ensure everyone understood it. I have good news and bad news for you. Let's start with the bad news. You're all characters in YouTube videos in which your planet gets into a situation where the moon breaks in half. For the audience, it will be a hypothetical story, but for you, these events will become a reality. The good news is that I was joking. There is no good news. But don't worry, the apocalypse won't start on your planet. Maybe just a little bit. Have a nice day. At first, the entire population panics. Then, a few days later, everyone calms down. Maybe it was a mass hallucination, and the moon will be alright. But at this moment, scientists have discovered the danger. A colossal meteorite is flying towards us from the distant depths of space. This meteorite is super fast and pretty flat, but has sharp edges. Fortunately, it will miss the Earth by a few thousand miles, but the moon won't be that lucky. The meteorite flies through our Earth's only natural satellite directly in the middle. So it passes through the moon, sweeps past our planet, and flies away into distant space. At this moment, all people can't take their eyes off the moon. The meteorite cuts it perfectly in half, gently, clearly, painlessly. So, what shall we do now? Will the Earth survive this? Our satellite breaks into 2 equal parts, but fortunately, they don't fly away from each other. The moon's great gravity attracts them back like a magnet. Scientists are sure that the parts will connect in a couple of billion years, and the moon will become the same as it used to be. But the coolest thing is that people won't feel any changes. Everyone around the world will celebrate this good news. The voice was wrong. But then, another problem appears. A massive meteorite in the form of a shoe is flying from the deepest space to us. It enters our solar system and approaches the Earth at high speed. The space boot crashes into one half of the moon and then flies away. Now, the moon is definitely breaking into 2 parts. The first half remains in the same place. The second one is flying towards us. A small meteor shower begins on Earth because of the falling moon fragments, but it's not so bad. Most of these rocks are burning up in the atmosphere. But almost the entire split-off half is falling apart around the orbit of our planet. It forms a stone belt. Now the Earth is like Saturn. Rotating fragments destroy part of our artificial satellites. Communication and the internet work inconsistently. It takes people a couple of years to restore a stable connection. The International Space Station no longer exists. Luckily, all the astronauts managed to return to Earth before half the moon got to them. So, moon rocks are flying around the planet, and people see half the moon in the sky. Life doesn't change much for the first few days, but those who live on the coast of the seas and oceans notice the consequences. The moon used to influence the tides. It was flying around the Earth and made oceans take an oval shape. There were tides on the side where the moon was closer. There were ebbs on the opposite side. But now, this schedule is wrong. Half of the moon attracts less water. Yes, the moon lost half its weight and began approaching the Earth. But its gravitational force has become weaker. Seabirds, many species of fish, sea turtles, and other coastal animals may not survive these changes. Their natural instincts associated with the moon help them determine the time for getting food, breeding, and flying south. For example, tiny turtles expect a strong tide in the morning. They run to the water, but the water doesn't reach them. Turtles can't hide in the ocean in time and become dinner for seagulls. Crabs can't lay eggs because the tide has started earlier than usual. Wolves go mad in the woods. They howl loudly every night and can't stop. The whole natural world can't understand what's going on. The human body is also feeling some discomfort. Many people have low and high blood pressure, and some experience severe headaches. Half of the moon changes the entire ecosystem of the planet. Adapting to new conditions will take several tens, maybe hundreds of years. A couple of weeks pass, and people notice the days are now shorter. The moon always slowed the Earth's rotation and made one day last 24 hours. The Earth is spinning faster now. The night and the morning come earlier than everyone is used to. Earth rotation speed has increased and reduced the number of hours per day to 15. People suffer from insomnia or oversleeping. The body needs time to get used to it. Work schedules are changing all over the world. Previously, people came to the office at 9 and left at 6. Now, they arrive at 7 and leave at 2 p.m. Sleep time got shorter, and people are really sad because of this. Progress slows down because the short working time. The technologies of the future are now 20 to 30 years late. Hourly pay remains the same, so bosses now pay less for fewer working hours. The whole moon stabilized the weather and climate on the planet. Look at Mars. It has 2 small moons. They quickly spin around it and rock Mars around on its axis. As a result, strong winds, sandstorms, and thunderstorms often happen on the red planet. Now the half of the moon that approached us takes the Earth out of stable rotation. This changes the seasonal temperatures in the world. It even gets hotter in hot places. And snowstorms are raging in cold regions. There are short, massive downpours instead of sunny weather. A typical breeze can grow into a hurricane and small waves into a tsunami. The seasons are changing faster now. Winters are colder and summers are hotter. Changing the rotation of the planet affects the Earth's magnetic field. Since the compass and navigation systems are unstable now, we need to recalculate where the north and south are. Birds can't fly south to wait out the winter since they don't know what direction to fly. Their inner compass is broken. Several hundred years have passed. People are entirely accustomed to the new conditions on Earth. New species of animals and fish have appeared. Birds can navigate the sky by the moon again. The planet's economy has been restored. Hourly wages have become higher. People now get enough sleep from 5 to 6 hours a day and work for 4 to 5 hours. The reduction of day and night has also affected the entertainment industry. Movies now last 1 hour. One episode of some TV series lasts 30 minutes. Life goes faster. An average person now lives to be 96 years old. In fact, the passage of time hasn't changed at all. Its calculus did. Several thousand years have passed. People look different now. Now they have big eyes that absorb more light. Half of the moon doesn't shine as bright as the whole thing, so the nights have become darker. It took the human eye a couple of thousand years to develop the ability to see clearly in this new dark. Animals need to navigate better in these conditions, so their eyes have become larger and more sensitive. During all this time, people have cleared the orbit of moon rocks. Several space stations fly around our planet. And again, people hear this strange voice that once told them that they were all characters in one hypothetical YouTube video. This time, the voice says, "Your story ends because the video ends. I'm sorry. Good night."